Let's memorize the unit circle. Here we go. Let's deal with the first quadrant only at this moment. So let's draw just the first quadrant, and by the end of this video you will have hopefully the entire thing memorized, but if you know the first quadrant you can extrapolate it to the other quadrants. So let's start with this, and we're going to put halfway mark here. This would be a 45-degree angle, and then we're going to put one for 30 degrees and one for 60 degrees. And let's start by talking about radians and the way I remember radians. Radians are going to have a denominator of 2 at the y-axis. Let's just do this one. So my denominator is 2, and it makes sense. This is pi over 2. It's pi over 2. And then it's going to be denominators of 2, 3, 4, 6. So 2, 3, 4, 6. 2, 3, 4, 6. And there's no way to remember that other than 2, 3, 4, 6. So 2, 3, 4, 6 as it falls away. And also 2, 3, 4, 6 as it comes up from here. So from the bottom it would be 2, 3, 4, 6. Okay. All right. Let's memorize sine and cosine next. And in order to do so, we will sing a song. Here goes. We're going to have a coordinate for each of these. We'll start with that. And cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. So far that was a pretty lame song. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. There you go. Okay. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. Notice that the exponents, sorry, wrong word, the numerators, very wrong word, the numerators count down. So this is, well, let's not talk about him yet. Square root of 3 over 2, square root of 2 over 2, square root of 1, which is 1, over 2, and then 0. Now, let's talk about him. This is really, and let's not complicate things too much, but this is 1. The square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2, but you can take the square root of some of those, like the 4 and the 1 and the 0. So let's not complicate things too much, but the numerators count down. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1/2, then 0. There we go. Let's get some tangents in there too. I don't have a song for tangents, but it's not going to be too bad. The tangent is the slope of the line that you're looking at. Okay? What's the slope of this line? 0. There you go. Oh, I forgot to put radians down here too. This will be 0 radians or 2 pi radians. We'll start with just 0. Okay? What is the slope of this line? Undefined. So our tangent is undefined at pi over 2. This is a, for lack of a better phrase, perfectly diagonal line. This is a line that has a slope of 1. Rise 1, run 1, which makes sense. We would rise square root of 2 over 2, run square root of 2 over 2. So tangent is 1. And this has a slope that is a little bit more than 1. This has a slope that's a little bit less than 1. And so let's figure out those. And we actually have already figured out those. But something that's a little bit more than 1 is this. Something a little bit less than 1 is that. Those are the correct ones, and we have already walked through where those come from. Now, this is not the most mathematical way of thinking about it, but this is what goes through my head. Okay. This is 1, a slope of 1. This is a slope that would be less than 1, and therefore it would be represented as a fraction. Okay? This is a slope that's a little bit more than 1, and therefore isn't necessarily represented as a fraction. Okay, I'm just going with a few ideas here. This is what goes through my head. Another way I've looked at the tangents before is, and this is not mathematical at all, but another way I've looked at the tangents before is this. If we are going down from the top to the bottom, then our numbers should look heavier the lower they get. So knowing that this is just 1, this square root of 3 doesn't have as much stuff attached to it. This one, square root of 3 over 3, even though the number itself is numerically smaller, it has more stuff attached to it and it weighs it down. So square root of 3, you don't have to write much. Square root of 3 over 3, you have to write a little bit more and it weighs it down as it goes down towards the x-axis. Okay. All right, let's take our ideas, extrapolate on them a little bit more, sing a little bit more, and we'll go from there. When I am trying to remember my radians, let's go back to radians for a moment. My numerators in this quadrant are always 1 pi. So it's always 1 pi over whatever. I'm going to call it DEN, for denominator. Over here, my numerators are going to be my fractions are going to be less than 1 pi. Okay? So it's going to be a denominator down here, whatever my denominator is. Remember, 2, 3, 4, 6. My numerators are going to be my denominator minus 1 times pi. Okay, so over here, if I was to draw this, then this would be over 3. Well, this is going to be my denominator minus 1, which would be 2 pi over 3. And then this one is going to be over 4. My denominator is 4, so it's the denominator minus 1, which would be 3 pi over 4. And then this one over here, my denominator is 6, is my denominator minus 1, 5 pi. There we go. Here I'm going to have denominator plus 1 times pi over my denominator. And this is the fun one right here. Denominator there. That. And how do I word this? This is going to be, 2 times my denominator and then minus 1. And here's the reason why. We're going to be just a little bit less than 2 pi. So for example, if I'm down here and I'm dealing with this one right here, my denominator is a 6. Well, 2 times 6 is 12. 12 minus 1 is 11. There we go. I hope this helps. Cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2 then 0. Sine counts back with 1, square root 3 over 2, square root 2 over 2, 1/2 then 0. Bye.